Okay, looks like I'm live. Hello, everyone. Welcome back to the stream. This evening, I have 2 days to go through. I have day 9 and day 10 of the Advent of Code. I don't know if I'll manage to do both because we are at the point where it starts getting difficult. So we'll see if I manage to go through them. I didn't stream yesterday because I got slightly distracted. I ended up doing the Advent of Code day 7 in brainfuck, and that took most of my evening, and I completely missed my stream schedule. But yeah, I have the day 7 part 1 in brainfuck on the repo, and I've posted a thing on Reddit, on the Advent of Code subreddit, that explains how this whole thing works. So that's the reason I didn't stream yesterday. Now, for today, we have two things, and I'm worried about them. As usual, I don't know what part 2 is about until I actually reach it. However, for day 10, today's exercise, I have seen a spoiler on the subreddit that didn't tell me exactly what the problem was, but makes me extremely worried. We'll get there when we get there. For now, we have day 9, and day 9 looks suspiciously easy. Um, I'm always worried when I see a grid of points and a to d space because I'm worried of like complicated geometric problems that I'm not familiar with. But the first part is just iterating through the list of points. So uh, I don't see any difficulty in part 1. We'll see what part 2 is about. I am worried about part 2. So let's do the setup. This is day 9. Let's copy the example so we can try our code against it. Parsing the input. Using parsec for this would be extremely overkill, but I'm still gonna do that because it's convenient. This is gonna be a list of points, and parsing each line with, and how do we parse a line? We get an x coordinate, which is a number. We ignore a symbol, which is a comma. We get y, which is a number, and we return a point xy. Now, what do we do for part 1? We want the biggest rectangle. So this is gonna be, given our input a list of points, this is gonna be the maximum value of, for each point and the rest of the other points, so point 1 and the other points in the tails of the points, which I'm going to rename all points for clarity, and I'm going to need tails, which I'm going to import from import data dot list qualified as L. So for each first point and the rest of the points, for each point 2 in the other points, we compute, is it the area? Yes. So this gonna be, this is gonna be the absolute value of, do I have, let's have a quick look. Px, okay. So I look at the x coordinate of the point 2, I do minus the x coordinate of the point 1, that gives me the x delta, and I do a plus 1, because that's always at least 1, even if they're on the same row or column. And I do the absolute value, so I get always a positive value. I do the same thing for the y coordinate. And my area will be dx times dy. And I will return an element, which is just that, and we will return the maximum element. Okay? Don't forget to run day 9 this time. If this works, we are expecting to find 50. Fix. Oh, yes, I renamed it to all points. There we go. Aha. That gives us 40 here. So we did something wrong. Huh. No, I do x coordinate minus x coordinate, y coordinate minus y coordinate. Okay. I compute the absolute. Oh. I should do my +1 after computing the absolute value. Otherwise, it will be nonsensical. There we go. Now I get 50. Let's try this value for my actual input. Okay, that's the right answer. As expected, part 1 was fairly straightforward. Now I'm worried about part 2. What is it about? They can only switch out tiles that are red or green. Okay. The rectangle you choose still must have red tiles in opposite corners. So we still must choose between 2 points of our list, but it must all be red or green. So it must always be contained within the shape. Ooh, okay. Okay. I suspect the naive brute force version that we're not supposed to use would be to just create a full map of the thing, and then, yeah, that would be probably pretty horrible. Let me just check an assertion, though, on the code, on the shape of the input, that suggests that every point in the list shares a coordinate with the previous point. Otherwise, we would have diagonal lines, and I don't think that's the case. So let me actually quickly check validate input of the test input, validate input of the real input, which is just going to be a temporary function, but I just want to do it with code rather than manually, just to check that my assumption there is correct. And this is going to be, hello, how are you? So my assumption that I want to check is that every point shares a coordinate with the previous point, therefore that all segments of the shape are vertical or horizontal. Let's just make that an IO thing. It doesn't matter. What I want to check, which is gonna be like this doesn't return anything. Yeah, I'm just gonna make it an IO. Or I should actually make it some. Yeah, it's fine. What I want to check is, given my list of points, is if I take the pairs. So that would be I'm not going to boolean. I'm going to say all, or and rather, and for each point 1, point 2 in the tails of the points, I want to check that they do have a coordinate in common, and I want to check that they're all different as well, probably, like there's no point that overlaps. So I probably want to do an XOR there. I know XOR is defined on bits, but I don't know if it's defined on Boolean. I would like to try on my own without help at first, at least. If I'm stuck, then yes, sure. Oh, it has a bits instance, so I can just do an XOR on the Boolean. Okay. So I want to check that this Boolean is different from this Boolean. Let's check that. True and true. Okay, so my assumption is correct. There is never 2 points that are the same in a row, and they're all either vertically or horizontally after the previous one. Visualizing is not a bad idea. I could do that with a very basic, I can import my sparse grid, which would be this sparse, I believe. And let's have a quick look. From list with width and height, and then a list of values. Wait, that's completely wrong. Okay. Do I have an insert? I don't. Okay. Oh, it's just a hash map of points. Okay. It's just a hash map of point to value, which means I could trivially do that by doing... So if I have my points, which is the real input, I'm going to create a grid by doing a hash map from list of the point and unit. I don't care about the value. Or true, I suppose. It's fine. For each point in the points. I'm just going to say M here. That gives me a hash map. And here, display with is going to require... I was going to require the range. I thought that... Oh, I already have this. Perfect. Okay. So I can just give unit here. I'm going to need data hash map strict here. So I create a hash map, and then I use this display with function that, given a point that I don't care about and a value that a value gives me if so maybe, well, maybe dot ou const pound, I suppose, of the value v, which I can rewrite 0.3 as being const of that. That should work. Validate input no longer exists. I have validated my assumption. I've removed the function. Points doesn't exist. This is the real input. But this wouldn't give me... I need to print that string. Oh, I do this after part 2, and part 2 doesn't compile, so, well, it doesn't work, because part 2 isn't defined. Okay, so it's big, is what I'm getting at here. I'm getting here. Is it just... what's the syntax? It's just the number. Okay, that's very big. So maybe let's not try to display it in the terminal. Seems like a bad idea. Yep, my computer is not happy with this. So let's not bother with that. Which also suggests that the brute force option of trying to just make the set of all points and testing every single thing will never be a good idea. That's fine. That wasn't the plan anyway. Okay, so if my naive idea is basically I create the set of all segments and I check that for every possible rectangle, like I do in part 1 there, instead of I check that neither of the 4 segments of the triangle intersect with any other segment. Because if they do, if there's an intersection point that is not on one of the points, then we're crossing the boundary of the thing, and therefore we are including tiles that are wrong. As long as we never intersect with any other edge, we should be fine, right? That's still kind of an n cube because we do for each point, for each other point, for all of the edges. So it's kind of an n cube, but that doesn't feel too monstrous. We could try that, and we'll see how that goes. Why do I have all points as a warning to something? Probably not. Probably it's fine. Okay, so I have my list of points, and what that means is I'm going to do the same thing. It's going to be a maximum of... Are you okay, computer? I'm going to recompile just to kill... There we go. I think the old compilation was still trying to render the whole thing in ASCII art in... Yeah, it looks a bit better. Okay. So what I'm going to try to do here is the same thing. We keep this, we iterate for every pair of points in all possible combination of points. But here we're going to want to check guard. And here we're going to want to check that neither of the 4 different edges intersects with any of the edges of the shape. So this is going to remain the same, but we're going to have to first check, keep only the pair of points such that we don't have any intersection. So here our edges are going to be... This is the diagonal, so... So we're going to have an edge that goes from the x coordinate of the point 1 to, and the y. So I have an edge that goes to from point 1 to the x coordinate of point 1, but the y coordinate of point 2. Let me draw some ASCII art, I think, just so that I can see what I'm doing. So if I have a point 1 here with x1, y1, and I have p2 here with x2, y2, that means I have p3 here, that is x1, x2, but y1, and I have p4 here, that is x1, but y2. Okay. So let's rename them. This is p1, p2. So we're going to have p3, which is going to be a point. We said at the coordinates x for the of p2, but the y of p1, we're going to have p4, which is a point at the x coordinate of p1, but the y coordinate of p2, and our edges are going to be p, and this is a 4, not an r, I don't know why, p1 to p3, p3 to p2, p2 to p4, and p4 to p1. That's our edges. Okay. And that we're gonna want to guard here is not any intersect outline of the edges, basically. What is the outline? That's going to be the thing we were doing, which is for each p1, p2 in the tails of all points. Oh, I need to be very careful. I need to be very careful here. Plus take 1 of all the points, because I need to also include an edge that connects the last point to the first point. So I'm adding the first point of the list at the back of the list, so that this thing that takes all of the pairs of the list actually also takes the last and the first. So that I do have all of the edges, and that's just what it is. Let me have a look. Oh, you did it with just 250? Oh, okay. Oh, but for the small one. Gotcha, yeah. Yeah, that's basically what I was trying to do for the big one, but the big one is a bit too big. And here, this is pure P1, P2, an edge, which is just a tuple of 2 points. So that's our outline. That's all of the edges of the shape. And now we just want to check that none of them intersect. None of the edges that we're trying here intersect the outline. Let's try that. What is, so intersect will be something that's given a list of point. In fact, I could try to redefine it as being on just 2 edges, edge 1, edge 2, basically. And that means that I'm testing for any of the edges that So given an edge E, I am checking. So I'm going to rewrite this as an all. And for each edge here, I am checking that not any intersect E of the outline. Which means I kind of want to rewrite this again. Rather than using an all and an any and something like this, this is and of for each edge in my edges, for each rectangle edge in my edges, for each outline edge in my outline, I return true only if not intersect rectangle edge, outline edge. And this whole thing returns true if there is no combination of our edges here and the outline edge that ever returns true from intersect. And now the only thing we have left to do is to define intersect. This still feels like a brute force solution to me, but I don't know how else to approach this problem. So we're going to try this. And if it doesn't work, then I'll look for something else. So here I have 4 points. Do I want to decompose this? Probably. It makes the big input small by making the distances only differ by 1. Oh, I had missed this. Gotcha. Okay, so we have I'm going to name them 0.1, 0.2, 0.3, 0.4. How do we check whether they intersect or not? There's an since we know that every single edge is either horizontal or vertical, I think it's going to be fairly straightforward. We can eliminate the case where they're parallel, because if they're parallel, they don't intersect. That's pretty straightforward. And if they're not, we can do some basic comparisons on the coordinates, I think. So how do we do that? So if parallel, the answer is false. Otherwise, we're going to do some more computation. Or do I... how do I write this? So here, okay. Let's think about this. Okay, so we have our edge 1 here, our edge 2 here. So let's actually call that the edge A and the edge B. So this is A1, A2, this is B1, B2, which means the dx of the edge A is the absolute value of PAX of PA2 minus PX of PA1 we might need to do the same plus 1 here, we'll see. Okay, so how do we know Okay, give me 1 second to read that. So you do a flip lookup that gives you, let me reopen your code again. And then you do a both from just in order to use to make that work and inject into the function result. What do you mean? Do you mean to be able to use them directly without having to do the both from just? Or do you mean how to use them directly into something else? I'm not sure I understand your question, sorry. Let me actually just, while you type your question, let me just do a quick foo here is gonna be a function that given some list of points, let's say some list of int will do something. We'll figure out what that is. And foo will do an unzip and then a both flip lookup. So that means I need to have access to some kind of map, which you're creating by doing. I suppose group is the name. No, it's not the name of something. Oh, I see. I'm an idiot. Okay. So the unzip creates a tuple of two lists, and on each of them you do a group. Two group values are similar. Then map head. Then sort. I understand now. I was confusing unzip with like a map. I was confusing. Like I was operating on the individual level. So I was wrong. And here then map swap after a zip one something. And that gives you a from list, and lookup does, okay. And both from just on that. Except since you've used that as a first argument to a function, on each side you have a function, so you do it from just dot ic. Okay, so that gives us two functions from int to int then. So what is, oops, let me scroll back. You want the actual value, not the just. So that you don't have to do the both from just combination thing. I see. So here you only have an association list. So you have basically a list tuple key value. On this, I don't know if there are functions that do a lookup, like directly without giving you a maybe. Any function that does that would do a from just under the hood, but I don't know if there is any. We can have a look. So I have a list of tuple a b, and I have an a, and I want a b. So I want a lookup that fails lookup just. There we go. That is part of the safe module. I disagree. This is not safe. The default lookup gives you the maybe, as we were saying. You can probably just do. Let me make this compile. Give me 1 sec. Let's say this, and let's here undefine. Undefine. Let's not try to run part 2. Oh, it's gonna fine. It's gonna just crash. And foo here. Couldn't you just do this? Wouldn't that work? I might not have both in scope. Is the thing. Both I don't have in scope. Where is both coming from? That's from bifunctor. Oh, or tuple, I suppose. You have it from tuple extra. Okay. From just will be from import data, maybe. Okay. Okay, that should compile, at least. Close enough. Here, the problem is you end up with... Why wouldn't that work? Why wouldn't a from just here at the end? Oh, because of course this is this, basically. I'm an idiot. This is other points. P2 is in other points. Wait, no, I'm wrong. This is P1, P2, and the rest of the list. There we go. All points. That's because here is what I need. Oh, there we go. So yeah, here, what flip lookup gives you at the end, after you're done with like all of that stuff, you're left with the output of this thing is a function from, so you've given already the map, so it's going to be a function from int to whatever is in your map, which in this case is probably going to be a point or something. So you have a function from int to point, rather a function from int to maybe point, and you want to turn that into a function from int to point. And indeed, if you try to do a dot, a from just dot, that's not gonna work because that isn't something that gives you a maybe. So instead, you combine it with a dot to combine the result of this thing with something else, and the thing you combine is dot from just, and that gives you, that then combines the output of this thing with this thing, which will transform your int to maybe point into an int into point. So yeah, more dots. That will work, but I would recommend keeping the from just explicitly, because from just is one of those functions that like from just is one of those functions that will panic your program. It will crash. It's one of those, like, you know, the what's the one that caused the Rust issue the other day? The unpack whatever it was. Like, this is a partial function, and having them very clearly, having a very small set of them in your program so that you can easily Google for them, so that if you have anything, like grep for them, so that if anything crashes, you can find where, is better to have an explicit call to from just than having it hidden behind some kind of library call, in my experience. But here, this is definitely a kind of case where I would rewrite this slightly differently, probably, just to avoid this gigantic point-free stuff. Is very fun, but there is a bit of a problem of like it gets very big. What do you do with this tuple of things? Okay, so let's imagine we just written this tuple of functions that what we want. Doing a both on an unzip seems perfectly fine to me, but you could probably name that function and like make lookup, I suppose, and make lookup will be at the end something of that type, given your list of int, basically. So given make lookup will take your list of int, which is going to be the result of doing this unzip, and will give you instead at the end a function from int to int. And that, since the right arrow is right associative, is the same thing as that. So you can rewrite make lookup as either a function that takes the list of int and returns a function from int to int, or a function that takes the list of int values and the key that you're looking for. And that is a from just of a lookup of the value map. Well, lookup of the key in the value map, because the key comes first, if I remember correctly. The key comes first. And the value map you can define as, you could even do as something like this. Well, you could do it as like the way you have done, which is you do a map head. Why the map head? So you get after the unzip, you get a list of values. Oh, because you probably have some way to you need to transform your int. I'm gonna remove the map head just to but like sort. Oh, of course, because you do a group. Of course, the group. Yes, there we go. You could do without the group by doing a sort and nub, which does that. So sort the values, nub to deduplicate them, and then zip them with those things. And rather than doing a map swap, you could do a zip with like a flip zip, basically. Something like that. And you would get the same thing, where that's the function that, like, you're returning that function, and that function sort the values, remove the duplicates, does a zip, but flipped. So this is the value, this is the argument, and then that's the argument, the lookup. The only thing here is there might be an upside to not give the points, so that if you're making something. Yeah, it depends on how you want to deduplicate, yeah. The only thing that would point, like, from an optimization perspective, if this function is defined in terms of the key, then this will be computed for each key. If instead you make it a function that, given this thing, does return the new function, so basically this, although this is the same thing, basically, from just lookup key in value map, then this is going to be slightly better in terms of optimization, but that's a small thing. Anyway, back to day 9. So here, this compiles, we just need to define intersect. So I was in the middle of defining parallel. Yeah, the thing is, deduplicating is pretty inefficient. On that note, you might want to have a look. Nub is the one I was using, which is defined in data list. Of course, again, please interrupt me with questions at any point. I welcome questions all the time. The nub that I was using is the default one in data list, but it is n squared because it uses only equality. Several modules define a nub ord, like data list extra, which is in n log n instead, because it uses the fact that there's an ordering on the thing. I don't know if there's like a sub nub kind of sort nub kind of thing. Or sort unique. There's group sort, I suppose. Yeah, since they have ord, you probably want to privilege one of those functions that use the ord property. They will be faster. So here, let's go back to parallel. When are the two edges parallel? Well, we know for sure that in either of those, either x, the dx, or the dy is 0. Sure thing, always happy to help. So I suppose they are parallel if dxa equals dxb equals 0, or dy equals 0. How do I write this? I want to just be like equality between the things because I want to avoid weird edge cases. So let's be very explicit. So this would be all equal to 0 of dxa dxb, or all equal to 0 of dya dyb. That's a bit inelegant. Using the all here on a list that I have just made, hopefully the compiler will optimize this for me. But I think it's slightly more elegant than saying dxa equals 0 and dxb equals 0. Or is that more elegant? I don't know. Let's be explicit. So this is dxa equals 0 and dxb equals 0, or dya equals 0 and dyb equals 0. If that's the case, they are parallel. If they are parallel, they don't intersect. That's the easy case. Okay. If they're not parallel, we want to find the intersection point. And what we want to do is check let's think about this. So I have two segments that I know are and let's take a slightly complicated example. Let's say I have PB1 here and PB2 here. So what I know here is those share a coordinate, and okay, to intersect, then whichever is horizontal must have an x coordinate on each side of the shared x coordinate of this one. and the one that is vertical must have one y coordinate on each side of the one that's horizontal. I think that's the only way they can intersect. And here I want to be careful. I don't want them to count as intersecting if they just touch. So it's going to be beyond the range, I think. I think this kind of like weird edge cases is going to make this the first problem where I don't get the right solution on the first try. Okay, so how do I write this in a generic way where I don't do if the first one is horizontal and the second one is vertical, or vice versa? How do I do this? Oh, I guess actually I could do that. I could do that by removing all of this and doing horizontal of an edge of P1, P2 is Px of Py of P1 equals Py of P2, and vertical is when their x coordinates match. And now I can do something such as I have edge 1, edge 2. If horizontal edge 1 and vertical edge 2 check edge 1, edge 2 with the horizontal one first. If horizontal edge 2 and vertical edge 1 check edge 1, edge 2, or edge 2, edge 1, otherwise, false. They're both horizontal or both vertical. Now, check will have the horizontal edge first and the vertical edge second. So here, I can get, since this is a horizontal... Yeah, the thing is, I'm basically, the structure of my part 2 is basically the same. The only difference is I'm making a check to like, is this rectangle within, but otherwise I think it's the same. Unless you mean going further in terms of reuse, in which case, I don't know. Possibly. So here we will have first the horizontal edge, which means I only care about its x coordinates. No, that's not true. I do care about... That's not true. I do care about its y coordinate as well. Okay. So I have the horizontal one, horizontal 2, and I have the vertical one and the vertical 2. What do we do in this case? So I need to check that the x component of the vertical edge is greater than the minimum of the x coordinates of the horizontal edge. And cut out all of the rectangles. I suppose you could... I don't know, because necessarily this will intersect with other rectangles, right? Just gonna read this as a list of conditions to check. So I want the x coordinate of the vertical one, which I'm going to do 1 point for this, but they're the same, to be greater than the minimum of the x coordinate of the horizontal and less than the maximum of the x-coordinate of the horizontal one, and I want the y-coordinate of the horizontal one to be greater than the y-coordinate and the y-coordinate of the vertical one. Let's try this in GHCI just to see if this intuition is correct. Yes. Okay, data bits not required. Data maybe, tuple extra. Yes, this was for the foo thing. This is no longer required. Perfect. Oh, this actually runs part 2, and it gives me something that is completely wrong. So, okay, we're gonna have to rethink this. First, let me try quickly. I'm gonna put it here. A GHCI. So I will want to check a few things. So intersect requires 4 points. Let's say I have, let's test the most basic case. I have 1, 5, 2, 9, 5 as my first edge, and my second edge is 5, 1, 2, 5, 9. And that's okay. This one. Oh, I'm expecting points there. So that's a point. That's a point. That's a point. And that's a point. That intersects. That's fine. That's what we're expecting. However, if this point that goes from 1, 5 goes only to 4, 5, then its x-coordinate, the right-hand side, will be similar to this. It will stop at 4, while the others will be at 5. So this should say false. It does say false. Okay. And now I want to say that I don't count the ones that are on the edge. And maybe that's my mistake. Like, I think this should not count as intersecting. It does not count as intersecting. However, we do get something wrong for the test example, test value. Okay, so let's try to have a look at the test. To try to see what's wrong. Oh, I suppose the problem with just checking whether we intersect with the thing is I would need to know. I don't know if this works. Because I have no way to know if all of my edge is outside or all of my edge is inside. So I think this naive approach of like, do the edges of my rectangle intersect with, that doesn't work, I think. I mean, clearly the value we get are wrong. So I need to rethink. I need to rethink this. First, I suppose I could check this, that this is correct. So printing this, but for the test input. Making sure that I do have all of the edges there. Although I don't think the problem is the code, I think the problem is this is not the correct approach. Yeah, I do have the last point linking to the previous one, so that looks correct. 7.1 to 11.1, 11.1 to 11.7, and so on. That looks good. So that's not the problem. Okay, so this might be a matter of like chirality or something, or I need to check. Column and row are only. Okay. Oh, this was already there. So I checked this manually, but it was already in the thing. Adjacent in the list will all be on the same row, same column. Okay, yeah. Which is why I can make this assumption that they're all horizontal or vertical. So here, here the thing is, I want to check whether my code is wrong for my current approach, or if my code is correct for my approach, but my approach is wrong. So I think I need to check first that this is working the way I expect before I can reject it as being the wrong approach. Because here I get all of the same value. Well, I get the same value. It doesn't mean I get all of the same. It doesn't mean I don't reject any of them. So here, let's return a maximum on first, and let's return the 2 points. So I will return the area and point 1, point 2. And I commented out part 2, so I'm not printing anything. I am returning from 11.7 to 2.3. Which is... Wait. Wait. I don't get... I get a value of 50 for something that is not the one I got in the input. So something is wrong with my code here. So let's do the same thing for P1, for part 1. Let's see what happens. So I have here 2 points, and they do a maximum on the first value, and I am returning the area and point 1, point 2. Yeah, that's the thing, is it worked. So I'm assuming something is wrong in here in part 2. No, I do get 50 for 11.7 and 2.3, which is not... The largest rectangle we can make in this example has area 50, and I agree. Oh, one way to do this is between 2.5 and 11.1. That's not the only way to do this. Because that is 9 times... Wait. That's 10 times 5. Yeah, it is also 50. Okay, that's fine. And I guess it is from... The edges are correct, I think. So I want to understand why this does not intersect with any of the edges of the outline. Because I would expect this to fail. I would expect this to be in classic Advent of Code fashion. I would expect this in classic Advent of Code fashion to work on the test input with a naive approach like this, and then fail on the real input because this approach is too naive. However, it doesn't even work on the real on their test input, so something is definitely wrong. So this is probably like 7-1 or something. Yeah, I see 2 1s, 2 3s, 2 5, 2 7s. So this is this is the second coordinate, which is the y coordinate, I suppose. Yeah, okay. So I'm saying from 11 7, which is this one, to 2 3, which is this one. And so my code is saying, oh yeah, no, this is perfectly fine. Despite the fact that there's more here, up there. So the one I'm currently considering valid despite the fact that it's not is this one. Nope. It is this one. And indeed, it is wrong. It does intersect with the shape of the outline. Aha. And so that's the problem I was thinking about. I intersect not with an edge, but with the point of an edge. And therefore, there are some cases where a point is valid and there are cases where it's not. And I need to check. How do I check? This is one of those chirality problems, right? It's like, do I cross an odd number of points or something like this? Because what I don't want to do... Because what I don't want to do is, of course, to create a set of all the tiles and then check that all of the things here of this area are all like the intersection of this set of points with the set of points of the thing actually like matches. That would be wrong. That would just be monstrous. Plus, there would still be the difficulty of defining what's inside. So I have to instead figure out a way to... Wait. Maybe I'm complexifying things. The fact that all of the edges are horizontal or vertical means when I leave a point, to go to another point, either I am going alongside. Wait, do I also have? Because I have the guarantee that they're all vertical and horizontal, right? That's listed here and I've checked it. And where is it? Tiles that are adjacent in your list will always be on either the same row or the same column. But can I make the assumption that they all rotate 90 degrees every time? And is that useful? It might not be useful. Okay, so if I redefine this in terms of, that's the kind of problems I'm bad at because I have zero experience with them outside of the advent of code, and a year is too long and I forget. So if I do this and I define an outside and inside purely based on rotation, basically, the problem is like I need to figure out if it's rotating left or rotating right, which is not something like I would need to first figure out if the shape, like which rotation it is, like is it clockwise or like starting from this point, is it going clockwise or anti-clockwise, basically, to be able to assign a in and out to each edge. I have the order of points in this thing. So I know maybe it doesn't matter about defining the inside and the outside. I know that this edge is going from this point to this point, and this edge is going from this point to this point. Therefore, I know I can check if I end up on the left or right of it, basically. Right? And what matters if do I cross, do I go from its left to its right when I touch the point? It's more complicated than that. But yes, I think this is 90% correct. I need just some more information about the edges because I need to be able to tell, oh, I'm in this edge is intersecting with this edge, and it's not fine because this point is on the outside, it's convex, but intersecting with this one would be fine because it's concave. That should be enough, right? It's not. It's not. I will need to check. Because here, if I say, oh, this point is convex, therefore crossing it means escaping into the outside, that doesn't work. I mean, it works, but then if I intersect with this, if I were to like stop on this point and try a rectangle like this one, then I would still touch a convex point, but I would still, that would not be a problem. I suppose I could. Okay, another idea. Whenever I look at the edge of a rectangle, it will be two edges going from a point that I know, so it will correspond to two edges in the graph, in the outline. So for instance, if I look at this point and I look at this particular rectangle, one of it which will be like alongside one of the edges, and this will be alongside the other edge. That's only true. That's only true if there's a 90-degree rotation at every point, which I think is the case. Because my reasoning would be then I can keep track of, for each edge in the outline, well, this one rotates left, this one rotates left, this one rotates right in a direction coming from this point, and I could do, okay, always a 90-degree, perfect. Because I could do something like this. I could do the edge from this point to this point rotates left, the edge from this point to this point rotates right. But I still need to know which one is in, which direction is in. I need to figure out which direction is, like, does it turn inwards or outwards, basically? Because if I know this, then I can look up, okay, I'm going vertically from this point. Let me look at the edge that's going vertically from this point. Do I cross the point? If no, then it's fine. It's all in bounds. Do I cross the point? Yes. If it was outbound, it's fine. If it was inbound, it's not. This, I see two downsides to this approach. First, I still need to decide what is inbound, what is in, what is out. I need to figure out the chirality of my list of points. That's still an issue. And two, what if I have a point that's not going alongside one of its edges? Wait, since they're all only sharing X or Y, but I don't know if that's a property that's part of this, actually. Is that mentioned in this? Because if it is, yes, I see how that's useful. Tiles adjacent to this will always be the same rows and column. Okay, that we know. Yeah, I don't think I can make this assumption. Okay. Okay. I think I just need to figure out. I need to figure out. I think this approach, but just changing it to like it's okay to intersect a point that is an inside point, not an outside point, a concave point, not a convex point. I think would still be fine. I don't think I can find a counterexample of this not being correct. And that would make it even easier because I don't even have to do edge intersection. I can just check, is there a point on any of my edges? And well, there's a point here and it's a convex, therefore no. Here's a point, it's a convex, therefore no. There's a point here and it's god damn it. No, it's a concave. So this one is fine. It's fine to intersect with that concave point. I think if I can do that, then I have a solution that should work. Now, I wouldn't know which point to connect next purely because the list is ordered, I think. I wouldn't know in the drawing, but I wouldn't know from the list. I'm just trying to figure out if there's a risk of. Well, I can't always necessarily check points. I still need to check intersection because the shape is actually more complicated than this. This example is too simple. Yeah, let's imagine this example. Or rather, this example. Wait, no, that still works. Okay, let's see. I think I can make an example that breaks. If I do this, there we go. Now, if I try to test this rectangle there, I need to check not just that I'm intersecting with a given point, but here I need to intersect with I need to check the edge. I suppose with the knowledge that everything is 90 degrees all the time, maybe checking the points is enough, but that feels like an assumption I shouldn't be making. I need to also be very careful. Hello, I am stuck on part 2 of this thing. I need to also be very careful about. I think my approach on checking the points only and not the intersection will not work. Because let's imagine I have the worst possible shape, which is something like this. I think the worst possible shape would be. just gonna up. Put points here, and I might just add one line of for readability and x. This, I think, is the nightmare scenario. Because here, with that approach of just looking at the points, I would consider this rectangle and be like, oh, we're not intersecting with any edge. This is an edge that's perfectly fine. That's an edge that's perfectly fine. That's an edge that's perfectly fine. That fourth edge, it's all good. So I think this scenario would be a nightmare. It would break every assumption I've made so far. Okay. So let's think about this. Because I think, again, this notion of chirality of like, am I on the left of the edge or on the right of the edge is the right approach, but I need to figure out what direction my input is in, basically. I guess I can do that by just looking at like doing a +1 or a -1 for the angle. And when I will end up with a multiple of 4, because like 4 times 90 degrees, and depending on whether it's a negative or positive, then I know whether it's going right or left, I suppose. Like if I'm living from this point, I'm going here, -1, -2, -3, -2, -1, -2, -3, -4. So I guess that's a way of doing the chirality, is to look at like, do I do 360 left or right, basically, and then I will know for each edge, given a starting point and a end point, and I could. Yeah, I'm trying. This kind of problem is not my specialty, and I'm basically trying to reinvent a solution based on from first principles, and that's why I'm stuck. But I think this idea of if I count the degrees, I can figure out the chirality of the thing. Therefore, like saying basically this edge, the left hand side is inbounds, the right hand side is outbounds, I suppose. Which I think would be a start, because a lot of those problems like this tend to use this kind of like information. Next, however, what do I need to check? I'm on part 2, yeah. Part 1 was trivial. Part 1 is just an n square and computing the area. I had one mistake because I was doing the absolute value after doing the +1, which was wrong. But part 2, yeah, no. Part 1 was deceptively easy. I was expecting something very hard on part 2 because part 1 was easy, and I was right. Okay, so computing the chirality of the thing, knowing from each edge which side is valid, which side is not, doable. Next, how do we make use of that information to check for intersection? I can go back to my idea of doing the intersection of all of the edges. And I guess the question is when I intersect with a point, basically. Haskell is a very concise language as well. Like there's a lot going on behind this. Like there's a lot of library functions, but Haskell tends to make for very terse solutions, which is nice. Because let me think. I think I have a plan for computing for a given edge. For computing for a given edge, whether its left-hand side is in bounds or out bounds. And therefore, I'm able to know for a given edge. So next, what can I do? I mean, it depends on the language, right? If this were C++, part 1 with the exact same logic would be significantly bigger. Because I'm using like maximum on, well, maximum originally. I've made some changes. Because maximum of this, and this is an int, like I'm already relying on the library function to compute the maximum of a list. I'm relying on the library function to like get the pairs of points for me. Like I'm definitely using like a lot of existing stuff. Okay, let's go back to part 2. Let's think about this again. So I figure out the chirality. How does that help me? I can still do the thing of does each edge intersect with any other edge? This won't work. This won't work because even if I know that this edge has the inside on its left, and this one has the inside on its left, and this one has the inside on its left, if I try this rectangle, how do I detect that this edge is out of bounds? Yes, this edge doesn't exist, but if I'm considering this rectangle, for instance, I'm considering this point 1 here and this point 2 here, the only way to reject it is to realize that this edge of the rectangle is out of bounds. I guess I could store, if I have the chirality information, then for each point, I can store north of it is in bounds, west of it is out. Like this is in bounds, this is out bounds, something like this. Even then, yeah, but this assumption that there's never more than 2 points on the same line is one that is not stated in the input. It's one I've not verified on my input. I might be like, I see how it could be useful, but I don't want to make that assumption unless I really have to. So I guess I could check that. I could check for, okay, so if I have for every point, for each of its 4 like cardinal directions, is it going in bounds? Is it going out of bounds? Then when I'm considering 2 points, like so, I can check for each of the 2 points that I'm considering, are the edges going in bounds in both cases? And here I can eliminate this one trivially because nope, this one is going out of bounds because it's on the y coordinate, this is going out of bounds. So if I do that, I can already eliminate some of those cases. Then it's a matter of checking whether we intersect any edge. Aha, and this is the interesting case. Because now, if we intersect an edge on a point, then we can use this I can use this to try to determine, is this one of those concave or convex points kind of thing? Because this point, regardless of which way I'm crossing it, I was inbounds, I'm staying inbounds. This one as well. So basically, if I do the check on the direction when on my 2 points, am I going out of bounds? And I do my intersection check I'm already doing. And in the case where I intersect a point that is a convex point, an outside point, not an inside point, and it is not on the bounds of my edge, then I must reject the thing. That feels generic enough to probably be fine. But that means now we have a lot of work to do for a solution that we don't know yet if it's correct, but that's part of the fun. So we are going to need to know study the direction of we need to study the direction of the shape. Is it clockwise or anti-clockwise? And then I can store for each point the information. Okay, so orientation will be clockwise or counterclockwise. Compute orientation given a list of point will be giving me an orientation. And this is going to be given my list of all points. I'm going to copy what I'm doing here because this is extremely similar. So for a list, which is all the points plus the first one, so I have all of the edges, I do the tails, so I get all of the pairs of a point and its and the next one. And for each of them, I must compute an angle. So this is going to be a fold over this thing. With a go step function, I suppose. My starting angle is 0. And at the end, I'll have to make a function based on this, because it will be either 4 or -4 if everything works well. And here I need to decide, I need to return 1 if this, well, I can't do that. I need 3 points. I need 3 points because I need to know, is this a 90-degree angle? Like left or right, basically. This is, again, making the assumption that there's no point in the middle of a straight line, which I think is an assumption I'm willing to make. I think it's true. I'm willing to make it. If it's not, I'll have an issue. That being said, I can handle this. I could handle this, actually. I could compute the thing and just say 0 in the case where it's aligned. All 3 are aligned. Okay, so I'm going to copy this thing here. And if horizontal... so take 1 will return an empty list if this list is empty. So here I'm putting an element at the end of the list. So if I were to do something like, let's have a list of 1, 2, 3, 4. If I were to do L plus new list, which is head of L, that works, but head is a partial function. And hello, everyone. And what I need to do here is, if I just do this, that's basically the same thing, except this doesn't crash if the list is empty. But I only need 1 because I only need 1 extra point at the end to link the last point here back to the first one. So here I want to compute the angle between... So wait, in this case, I know that... Nope, that's day 9. I'm late by 1 day. Yesterday evening, I was too busy doing day 7 in Brainfuck to stream, so I didn't do day 9 yesterday. That's what I wrote yesterday instead of streaming. It's on the repo, and I wrote a thing on the Advent of Code subreddit about how this works. And yeah, I got completely nerd sniped by it, and I forgot to stream. Okay, so here I want to figure out, I have 3 points, and I want to figure out, are they going left, are they going right, basically? So I guess there are 4 cases to identify. I want to check, is this a horizontal line, and therefore this one is vertical, and I need to check... Okay. Can I do this with just... I know how to write this. I'm trying to figure out how to write this in a way that's elegant. Okay, I have an idea. So I think I can do this with the delta 1 is the x coordinate of P2 minus the x coordinate of P1 plus the y coordinate of P2 minus the y coordinate of P1. Since one of those will be 0, this will give me a delta on the direction of the edge. So if the edge is going right, this is going to be a positive value. If it's going down, it's going to be a positive value, and so on. Will that be enough? No, I still need to know the orientation. Okay. Because I can't just do the sign of the thing. Because if it's x increasing and y increasing, it is... Can I do this with, like, complex numbers? Can I do this with complex numbers? Can I do, like, multiplied by I or something like this and check whether we get the same sign at the end? This would be more elegant than doing a 4-way if. Nah, let's do this. I want to get out of this, so let's do this. This would be actually 1. And I guess, and let's see, let's write it down and let's see if there's a pattern we can find that makes it easier. If we are going right, and down, and then down. I'm trying to solve it blind for now, yeah. If I'm really stuck, I'll move on. If I'm really stuck, if this approach I'm currently doing doesn't work, either I'll move on to day 10 or I'll look a solution. But I think if I don't have an interesting thing to try, I think I'll just move on to day 10 and solve it off stream if I'm really stuck. But now that I have an approach, I'm going to try it. And if it doesn't work, I'll just move on, I think. So if I was moving to the right and now I'm moving down, that is clockwise. So this is +1. If I was moving to the right and I'm now moving up, this is -1. It's going to be 8 cases. But I guess if that's the case, I can rewrite this as signum of dy2, and I save one case here. If I am going down, then if the second edge is going right, it's a counterclockwise. So this would be minus signum of dx2. Okay, with this, I can probably reduce it to 4 cases. Otherwise, we're going left and then up. And this should probably be the opposite. So this would be minus signum signum. Okay. That's the wrong. There we go. And here, this would be an error, incorrect input, I suppose. Okay, so if we try this, now we should get 1 or -1 on each angle. At the end of this, we do a fold and a step. Our step is, I suppose, just a sum, actually. So we associate 1 or -1 with every angle of the thing. And at the end, we check, validate the result. And validating, we don't need this anymore. Validating the result will be four. It means we rotated to the right. This is clockwise. -4 would be we rotated counterclockwise. I'm not sure this is going to be correct in terms of syntax. We'll see. And otherwise, if I get any other value x, so let's try this and let's check what it tells me. I have show. So let's try and remove this for now, and let's print compute orientation of the test input and the real input. It's not supposed to be here. This is still supposed to say this. And oops, I've messed up my layout again. Give me 1 sec. Good enough. What's wrong here? Is it just a matter of this is, or is it just not happy with the -4? It might not be happy with, no, okay. dy2 should be an int, but it's saying expected character. Fascinating. We agree that signum of 3 is 1 and of -3 is -1. Okay, so it's fine. So those things should all be ints. So this should be a list of int, to which I do sum and then validate here. Takes an int, returns an orientation. What are you unhappy about then? It expects a list of int? That feels incorrect. Oh, of course. This is a do block in the list monad. Therefore, the last value must be of type list. Therefore, I need to use a pure if I want to return only one element. That is the problem. There we go. And here I need to show this value. Got incorrect value 1, so I've messed up something. So instead, let's return a list of int, and let's do that. And let's see what we get for the test input. So the test input, which is this thing, I get, we are going from 7.1 to 11.1, so we are going right, and then we are going down, because we're going from 11.1 to 11.7, so that's a right angle, so that should be a 1, okay? Then from 11.1 to 11.7, we are going to 9.7. That should be right, and we have -1. So, okay, our computation is wrong. So if I'm going down, so here I'm going from 11.7 to 9.7. So the delta x of P3 minus P2 will be -2. So since I'm going down, dy1 is greater than 0. Then indeed I want 1 if this is negative. Wait, so that should be 1. Let's debug this in excruciating details for 3 points and an int. That is my list, and this is the result. And I'm returning pure of P1, P2, P3 result. And here I'm going to do, instead of a print, I am going to do a traverse print to have one per line. This is probably just like a sign error somewhere. So we have 7-1 to 11-1, and then 11-1 to 11-7. That's going right, and then that's going down. That's a right angle, therefore we get a 1. Then we have going from 11-1 to 11-7, that's down, and then from 11-7 to 9-7, that's left, and we get -1. That is indeed wrong. So, okay, so I was correct about where the bug is at the very least. And that's the case where dy1 is greater because it's pi yp2 minus pi yp1, which is 7 minus 1. It's greater than 0. Therefore, we're looking at the signum of dx2, which is 9 minus 11. That's -2. The signum gives me -1. I do minus on that would be 1. Huh. I do P2 minus P1, P3 minus P2. Where is the bug? God damn it. Px minus Px, Py minus Py. That's why. So now I do have a right angle there. And then we go from 11-7 to 9-7, which is left, and then from 9-7 to 9-5, which is up. That's a right angle, we get a 1. Then 9-7 to 9-5, which is up, and then 2-5, which is left, we get a -1. Then 9-5 to 2-5, which is left, then 2-5 to 2-3, which is up, we get 1. Okay, that looks better. That looks better. So now if I go back to just pure result and I put the validate back, on the sum, and I get the orientation here, and I remove this thing and I just keep with a print. I got a 3, which suggests that I am forgetting 1 point at some point. Okay, let's undo this then. Because I rotate... Ah, yes, since I have only the 1 point at the end, I am missing the angle formed by that point. That's the problem. So here this would be a take 2 of the points. And now I should get 1, 2, 3, 2, 3, 4, 3, 4. Okay, and now, finally, at long last, this should be fine. Orientation again. And this is a validate of the sum. And here we return pure of this nonsense. Let's check. Come on. And here, let's just print this result. I get clockwise for the test input. And I get clockwise for the real input. Okay. That means now I can create some kind of mapping of for each point, where does each of its coordinates land. based on whether it's clockwise or counterclockwise, which then I should be able to use for my okay. So how do we do this? This is going to be what do we need to know? We're going to need to know for each given point in the thing, we're going to need to know for each direction whether it's inbound, basically. And I guess a hash map from thing to Boolean, I could rewrite this as a hash set of point and direction, and the Boolean is just, is it within the set, basically? So now I have all of my points, I have my orientation. What I can do is some kind of map from list. My list is going to be computed doing exactly the same thing here. I need all three set of points, I suppose. Do I? Yes, I do, because I need to know which direction I'm coming from. So I need to redo this, basically. Oh, I'm almost tempted to rewrite this as one big circular function that feeds the clockwise thing in the output. But let's not do that yet. Maybe when this works, if this works, maybe let's try to do it in a circular way, because that would be fun. So we do that. And now, because what I'm doing is I'm recomputing whether it's clockwise or anti-clockwise, basically. I'm redoing the exact same thing. Can I avoid redoing the same thing? No, the thing is I need more information here. Yeah, I will probably want to merge those two functions at some point. Because what I need to know here is I want to know which directions are safe, basically. So it is this nonsense again. Except I think here I'm going to have to list... Well, no, because if it is against the orientation, then all four directions are safe. By definition, if it's a concave thing, then both north, like all north of south, west, and east are all fine. It's only if it's convex that I need to test this. So I can rewrite this as, in this case, it is all four cardinal directions, which I have from my library. And here, this is the case where and dy2 greater than 0. Ah, no, I need to check. God damn it, that's complicated. Okay, I can do something like this. Compute angle orientation. And that's given 3 points. Give me the orientation. And that's this, basically. Which will be the int I need for the function below. P1, P2, P3 is this function. Oh, that's sine is what I meant, not what I meant. What did I mean there? Oh, sine actually is correct. No, I need the sine, I need the int value. Okay. So that's computing the shape orientation, and that is replaced by pure compute angle orientation sine from P1, P2, P3. From sine well, which is going to give me an int. Clockwise is 1, counterclockwise is -1. Okay, so here, computing the orientation of the shape, all of this goes away. And when I'm computing the point, the information of a point, I can look at this for P1, P2, P3. That gives me a value which is 1 or 0, 1 or -1. And so if this orientation sign is different from the orientation sign of the one of the shape, so shape orientation, that's the case where this is an inside angle, so a concave one, and the safe directions are all 4 of them. Otherwise, if, and I need the dx dy thing here, I'm sure that there are assumptions I could make to make this easier. because now I need 8 cases if the x greater than 0. I'm just going to copy them from here. I guess I could rewrite. That's fine. Okay. So if this is a point where we're coming from the left, we're going right, and then we're going... Wait, no, that doesn't work. This approach is monstrous. I cannot believe this is the right approach. This is so much code. This is so complicated. There must be a better way. So I'm trying to say is basically, I was going right, and now I am going up, and this shape is going clockwise. Therefore, the points that are safe are... Oh, I can do something a lot simpler. In a point, I have rotate 90 degree somewhere. Turn 90L to 90R. So that means... So the base direction... Oof, you're asking a wonderful question that is definitely not a rabbit hole. Template Haskell is basically an extension of the language, like many things, that allows to run Haskell code at compilation time. And basically, it is a set of libraries on top of this extension to manipulate basically the AST of the language to generate code. An example of which is automatic instance generation or automatic expression generation. For instance, not in this project, but in this project, if I go to, where would I go? The AST, perhaps. AST, and I go to, let's say, validated. In this project here, I have somewhere this statement here, make lenses for a type called typed. This thing is a template Haskell expression, so it's evaluated as Haskell code at compile time. And what it does is it generates a bunch of new declarations in the file based on information of this type. Since this is lenses, in this case, it does, where is typed define? It generates a lens called type info and a lens name typed value without the underscore, because it looks at the shape of the type, looks at the name of the fields, and adds new declarations to the file based on this. A very common other use of it that you will find is derive JSON. The ASN library, which is the most common one for JSON handling, has a thing where it automatically generates the instance of from JSON to JSON for you by using a template Haskell expression, so something that's evaluated at compile time. That's probably because you have used So it is unrelated to what you're doing, if I remember your example correctly. But what you might have done is you might have done, let me go back to a function, let's go here. You might have written something like this with the dollar sign and the parenthesis close the dollar sign. And if you have, this is the way template Haskell is invoked. And I assume that this, if you put a space there, it will be fine. Let me try this in GHCI. If I do, I don't know. What do I want to do? Map first of a list that is just 1, 2. That should be just fine, and it should give me a 1. However, if I remove the space between the dollar sign and the parentheses, this isn't interpreted as a template Haskell invocation, which is incorrect here. So the compiler interprets this as a slice that is supposed to be used at compile time. So that's your error there. Spaces after the after the dollar sign. And template Haskell allows for a lot of magical things. So like automatic instance declaration is a common one. Another thing is embedding files at compile time. Since you can run IO at compile time, you can go read files in the disk and embed files in your program at compile time. The embed file library uses template Haskell. Embed file. I swear I could type file embed. There we go. That's the one. So if you enable template Haskell, this expression with the path thing will be at compile time evaluated into a string, which is the content of the file as it was at compilation time. And this library does some magic as well, so that the file is registered as a dependency of the project, so that the compiler knows to recompile if that file changes. So back to this monstrosity. I still think that I'm doing something wrong because this is incredibly complicated. And it shouldn't be that complicated. So the base direction, if I'm going right, do I want to normalize? Instead of using north, south, west, east, do I want to normalize? Yeah, probably. In which case, that's a lot easier. Okay, that's a lot easier. So if I do that, the direction in which I'm going is... Do I have... I have int instance on point, which is completely wrong. So that would be the unit vector of the direction in which I'm going at this point would be signum of P2 minus P1. Okay. Now, if this orientation sign is different from the orientation sign of the shape orientation, then all of the directions are safe. Which means I return wait, there's already something called unit vector, I think. No, it's called direction vector. all directions from this point are within the bounds if I am rotating in a direction that's not the same as the one as of the shape. Otherwise, I am rotating in the same direction as the shape. Therefore, continuing in the same direction is off bounds. Going back is in bounds, and going against the direction in going in the direction of the shape is in bounds. So I'm gonna regret saying that this year was easier. So if then shape orientation, I'm gonna need the equal thing here. If it's clockwise, then the points that are safe, and I suppose I need to do this way. Are rotating how did I call it again? This is an old code. It's called turn. I'll rotate. Weird. Turn to the right of the unit vector. Do I have a turn 100? No, I don't. Okay. But I do have minus unit vector. Otherwise, let's turn left. Okay, this nonsense should be more or less correct. Let's try having a look at compute point info of the test input. That gives me a hash set. Let's do a print. So I'm going to need to have data hash set qualified as S in scope. This doesn't align, which means I have a syntax error somewhere. Probably this is not fine. Also, this isn't a... No, okay, it returns a list, that's fine. No, it still doesn't align here, so there's still a syntax error somewhere in this code. We will see what it complains about. Part 2 can go away for now because it's all wrong. And here I will want to do a set to list and a traverse print to put 1 point per line. So here the function is not finished properly, otherwise is missing the arrow. Compute shape orientation. This was my example for the template Haskell question. Can go away. M from list is not imported. I require hash map. I'm going to use the strict version. Wait. I don't need the hash map. We decided on the set in the end. So this is a set from list. Haskell uses a different symbol for inequality. Point is not in scope. I am interested in P2 in this case, which is the point around which I'm rotating. This requires the orientation, so I need I could assume it's always clockwise since I have computed that it's clockwise, but I don't want to make any assumption about the shape of the input if I can avoid it. Is it orientation second? No. It is. Okay. Okay, so what do we have here? I am saying that in... Let me copy the shape as it appears in there so we can have a look at whether this makes sense. I am saying that x7, y3, it is this one. I am saying that if I'm going with x equal 1, so I'm going to the right, this is inbounds. Okay, that looks correct. 7, 1 here. If I'm going to the right, I am inbounds. That's correct. Actually, can I sort those? So I have them sorted by, that would be a lot better. Sort. Okay, so now I have for 2, 3, which is this one, I am saying that the points that are safe are going down, y equals 1, and going right, x equals 1. That's correct. For x2, y5, which is this one, I am saying going up, y minus 1 is safe. Going right, x equals 1 is safe. Okay. For x7, y1, which is this one, the points that are safe are going down and right. Yep. 7, 3, which is this one, should have all 4 points correct because it is a concave point. Okay, that seems to be working. So now I have for each point in the graph what are the directions that are safe for this point. That should be enough to actually solve the problem now. Okay. So, part 2. I have... So I'm going to compute the shape orientation by computing the shape orientation from the list of points. Then I'm going to compute safe points. Oh, safe directions, which is this hash set by doing the compute point info, a horrible name for a function, but that's where we are, using the points and the shape orientation. This operator is from arrow, isn't it? Yeah. Yeah, arrows are a... What's the right adjective here? I was going to say unpleasant. That's not correct. A maligned part of the language. DHC's support for arrows and arrow syntax specifically was broken for several versions of DHC and is the only place in the language where I've ever encountered like DHC internal compiler errors. And arrows are a fascinating idea that in practice I've never really seen a use for, but it has some very useful operators. Like, yeah, sure. First and second is now a function that like takes a tuple of tuples and does the extraction correctly. It's a combinator. It's not as cursed as the Blackbird, but you know. Okay, so now we have our shape orientation. We have our safe directions, which means we don't need the shape orientation anymore, I think. We have our outline, and I think this should be correct, provided that we rewrite intersect. Because now intersect is gonna need an additional thing. It is going to need our hash set of point. Okay, so let's go back to intersect. Where is it called? It's called here. This is going to require our safe directions. Okay, and the other thing we need to check is for all 4 edges, I need to check okay. So what I want to check is I am on point 1 and I'm going towards point 3. Is this a direction that is labeled as safe in my computed hash set? So I'm from point 1 and I'm going towards point 3, which is signum of point 3 minus point 1. Is that in my thing? If no, it means I'm stepping from one of the points of my rectangle, I'm stepping outside of the shape. And I do that for all of them. P3, P4. So now I have checked the horrible case, the worst possible case has been eliminated. The one where I have this, with this being the shape. Oh, I should probably. There we go. Where this is the shape and this is the shape, and so on. Because this case is monstrous because I have 0 intersection of my edges with other edges. But here I would detect, if I were to try this rectangle, I would reject it because I would be, from whether it's from this point to this point or from this point to this point, I would look at one of those 2 points towards the other and I'd be like, oh, I'm stepping out of bounds. So I would detect this case and I would reject this one now. Okay. So that means that now the only thing we need to figure out, I think this is all correct. Well, I'm going to rewrite this, I think. This check thing is going to go away. But now, basically, I have a vertical edge, and I have a vertical edge. And what I need to check is, do they intersect at all? And if they, I can very trivially reject the case where they completely intersect, as in there is no equal sign involved. That's just this case there. That's trivial. That's easy to reject because if I'm crossing an edge, I am going out of bounds. The tricky case that I want to analyze is the case where a point is on the edge. Because then it will depend on whether this point is an inside point or an outside point, basically. I think this will be enough. Now the question is, how do I write this? How do I write this piece of code? Okay. I can reject the trivial case of this. I can reject this trivial case. And I can reject the trivial case where it just doesn't intersect at all, I think. Which would leave me with the case where I have an intersection. So let's write it down very explicitly at the risk of being verbose. Oops. And we'll deduplicate otherwise. So does not intersect is when the x coordinate of the vertical one I suppose that should be part of check. Okay. Otherwise, I'm gonna keep this one. So okay. So let's write this. If the x coordinate of the vertical thing is less than the minimum of the horizontal edge, it does not intersect. That's easy. We can reject this case. If it is greater than the max, it does not intersect. We can reject this case. We can do the same thing for the y coordinate of the horizontal one is greater than the y coordinates of the vertical one. If our horizontal line is above our vertical line completely, it doesn't intersect. If it's below, it doesn't intersect. Okay. Now, if it has a clean intersection, we can also so this would be the x coordinate is do I want to introduce aliases for this min max thing? Because there's always a risk I'm gonna get it wrong if I don't. That's fine for now. So if could I actually do something smarter since I'm gonna do is greater than the min is less than the max? I could introduce a within. within will be strictly within, and that's going to be x greater than min v1 v2, and x is less than max v1 v2. So here this would be px of v1 is strictly within, that's actually more verbose, I don't know, pxh1 pxh2 wait, I know in this case that there is an intersection. The question is whether it is I have an overlap of the points or no. So I could perhaps, I still think I want to eliminate all the easy cases. So that's, so the x coordinate of the vertical line is clearly is strictly within, and the y coordinate of the horizontal line is strictly within. That is true. That is an easy case. That's an intersection. Okay. Now, if we are in any other case, that means we have a point on the line. Oh, I might not need this set of checks here, because I would find an intersection with this point. This edge would see an intersection with this edge on this point, basically. Unless I don't do point-point intersection, and I use that check for this, because it might make this monstrous function a bit easier. Okay, so here what I do is, therefore, I am only interested in the cases where I have a point in the middle of an edge, since I have already eliminated the other cases. So I am interested in one of those strictly within, but not both, basically. So if both are true, it intersects. But if either of them is true, but the other is not, that means I have a one-point intersection. Like I have this case, basically. Because here, the x coordinate of the vertical line is strictly within the bounds of the horizontal line, but the y coordinate of the horizontal line is not strictly within, while not being outside. So it means it intersects on the horizontal line. Okay. So that's the case here. This case is the vertical line intersects with the horizontal line. I need to decide which point it is. Which will be whichever point of the vertical line is on the same y value as one of the points of the horizontal line. So if that's the case, P1 is the V1 is the one that intersects. Otherwise, it is V2. Could I get rid of... Could I simplify my hash set? Could I simplify this test? Not really. Because here, at this point, since I don't check corner cases, just edge cases, I don't care whether... Okay. Okay. So here I want to check that this point V1 intersects with the horizontal line. I want to check that its left and right points are in bound. So I want to check of V1, that point where the intersection happens. And I want to check that left, well, west and east are both in bounds. If it's V2, this is that. I still believe there's definitely an easier way to do this. So here, this is the other case. So that's Px H1 equals Px V1. And that's H1 here, it's H2. And I want to check north-south. This, now I can write check in bounds of a point P and direction vector V1, direction vector E1, E2. This will be if one of the points is in the set but not the other, I am intersecting. So this would be if they're both, that means I'm not intersecting. If only one is, I am. This is monstrously complicated, but there's a chance it might work. Yeah, I'm not giving up yet. Yes, I can't do a... I can't... Why can't I do that, actually? If I'm applying this to this, it should give me... Okay, well. I'm gonna rewrite it as... like this. And now I can do the same thing here. Okay, nothing urgent. I will check that later. And here I didn't need to do the last thing, which is... This is going to be a nightmare to debug if it works on the test input and not the real input. Okay. Yeah, a lot of AOC is test code. Like a lot of the things you apply in AOC doesn't actually really translate to real code. A lot of like actual difficult stuff, logging, tracing kind of things, doesn't show up at all in AOC. It is very self-contained. It is still interesting, but it's not the same thing as real production code by far. Points doesn't exist. It's called all points. Let's not even try to print. Let's just do that for now. And not exhaustive. If I ever encounter something else, I'm just going to say undefined for now, just because I wanted to compile. Okay, what do I get? I get undefined. Fascinating. So what does that mean? So that means I did not get the x coordinate of my vertical line being less than the minimum of the horizontal line. I didn't get the x coordinate of my vertical line being strictly greater than the maximum, or the y coordinate of the horizontal being less than the minimum of the y of the vertical, or the y... Okay, so here, this is the case that failed. Let's try to see. What case did I not consider? So 7, 1, 11, 1, 11, 1, 11, 7. Okay. So 7, 1 to 11, 1, that's the horizontal one. And 11, 1, 11, 7, that's the vertical one. They do intersect at the corner. That's the problem. And intersecting at the corner, I think we decided that intersecting at the corner would be false, because I'm already checking the corners with this complicated stuff here. I get 24, and that is correct for the test input. I want to believe. Because I connect 9, 5 to 2, 3. Well, there is no time like the present. I get this. Oh. Technically, first try. Okay, now I'm really curious. What's a better approach? Because I really reinvented this kind of horrible stuff from first principles looking at this, there must be easier, right? Cross product. Can you expand? I'm really curious what that means. Oh, as a way to compute orientation without actually computing the sum of the angles and checking whether it's plus 360 or minus 360. I suppose, yeah, I can see how that would work. But even if you do the cross product, then you still have the thing where you still need to do, but you still need to, okay, so it would simplify computing the orientation of the shape, right? Which is this thing. Ah, so you're doing the same thing I'm doing. Except you're not generating the list of edges. You're traversing the points in order so you can keep track of the chirality to check every rectangle. I see. Okay. So it means roughly. So going through all the rectangles and then going the path like I'm doing is more or less the shape of the correct solution. But oh, raycasting. So raycasting would be the thing, which is kind of what I'm doing in the sense of like how many things do you intersect, basically, right? I'm curious because like this area is really not my forte. Geometry stuff is not my forte at all, which is why I was kind of dreading part two of this, and I had to reinvent the solution from scratch. I'm glad I managed, but it was not a guarantee. Okay, yeah, no, I'll definitely have to go read some of the other solutions. What also worries me, like a more personal level, like managing to solve the advent of code is one thing, but my whole point with making a stream is also like trying to showcase some interesting stuff. Here, I don't think I could showcase a very interesting approach because I didn't have an approach to showcase. So I hope this was still interesting to watch by that the Haskell part at least was interesting. So what they did at the end is I'm happy to talk more about the list monad. What I end up doing in the end is basically I compute the chirality of the shape itself. Is it clockwise or counterclockwise based on the list of points? Then for each point, what I do is I create I store for each point which directions are safe, which is super overkill. There's probably a way to do better. But basically, for this point, this is not safe, this is not safe, this is safe, this is safe. And what I do afterwards is for each rectangle, I let's say this one, for instance, because I was trying to handle as generic a case as I could, I check for each of the four edges of the rectangle I'm trying to see, do the points near the points I know are they're all in bounds. Here, for instance, if it's this point and this point, it would be rejected because here we're stepping out of bounds, basically. And if a rectangle passes that test, so for instance, this one would, because for the two known points we are stepping in bounds, from this one we are stepping in bounds and in bounds, here in bounds and in bounds, then I traverse my whole path and I check for intersections. And I check for intersection by checking, and that is this monstrous function. I'm sure there's a way to do better. There you are, which is basically, are we completely not intersecting? I can eliminate the case false. Do we have a clean intersection? Like this, yes, we intersect. And otherwise, I look at the point. Like if we intersect on a point specifically, then I only consider it an intersection, so something that crosses the boundary, if this point is an outside point, a convex point, not a concave point. I don't know if this approach will work for any shape, but it worked for a lot of shapes, including the ones of my test input and my real input. Okay, whew. I am not proud of this, but I'm happy it worked. This is not elegant. But yes, the list being a monad is very convenient, because the way monad is defined on list. So if I look at this operator, in the case of a list, it is given a list of A and a callback from A to... Oh, so if I know it intersects, so I know if it intersects, it crosses clearly, then I know I can reject the rectangle because it intersects with one of the edges of the shape. Therefore, one of the points has to be outside, or at least part of the edge has to be outside. If it crosses a point, only on a point, then if that point is a concave point, it's fine. Otherwise, if it's a convex point, I also reject the edge. So basically, as long as my intersect function returns true for any combination of edge of the rectangle, edges of the shape, I say no, and I reject the rectangle. But yeah, so the monad operator on list is just for a list of A and a callback from A to list of B, return a list of B, which is basically a concat map, which means that you can do things in a list that return more and more things in the list, and it will do a concat map of all of the operations, which is kind of a list comprehension. Like a list comprehension where we do x plus y for x in 0 to 5 and y in 0 to 5. That's this, which in Python would be 4x in 4 y in, but we are Haskell, we use operators instead. And this list comprehension can be rewritten as, well, open a do block for x in 0 to 5. You can see this as being a concat map from 0, 5 to something that takes x and do something with it. For y in 0 to 5, concat map to something else, which needs to return a list. So here we need to return a list, which could be just one element x plus y, or could be x plus y and x minus y, for instance. Let's do that. And that gives us the concat map of all the different steps, and that's our list. I use this all the time, especially since the way monad fail is implemented. Monad fail is kind of a controversial and old part of the language. Monad fail is basically what to do in case of error. And that's basically how do we handle something that goes wrong, which is not great because it's basically some monads will just panic, some others will not. But in the case of list, I know that guard just returns the empty list. So if I try to do, well, fail does, and guard is implemented in terms of fail. So if I do guard false, and I'm trying to create a list of int, it just gives me import control monad. Okay. It gives me an empty list, basically. It doesn't fail, which means if I go back to this example, where I do this, I can do the equivalent of an if in the list comprehension, or what Python would use as an if in the list comprehension, as being a guard, I don't know, even x. And it does exactly what you may expect, except for the fact that, of course, I forgot to open the do block. But otherwise, that would have worked. There we go. And that's I find extremely useful to be able to organize some of my list creations like this. I use this, for instance, here. Let's look at part 1, where I am going and doing a maximum on a list of points, which is for each point and the rest of the point, and then for each point 2 in the rest of the points. So for each pair, point 1 with all of the other points, point 2. Return a, this pure is basically return a list of one element. So this is a concat map, concat map, concat map. That gives me the list with all of the areas for all of the point, all the cross section. No, that's not the thing I'm thinking. Cross product of the points. And then I do maximum on that list. Okay, that was day 9. That was a struggle. Now for day 10. So for day 10, I try to not know part 2 ahead of time because I think it's more interesting if I try to discover it live on stream and I try to figure out what's happening. I have seen one spoiler about it on Reddit when I was writing my my write-up on how I've done where is it? On how I've done day 7 part 1 in Brainfuck. I saw several people mentioning I saw some people mentioning Z3. And if Z3 is mentioned, it means part 2 of day 10 is a lot worse than what I thought it would be. Because day 10 is looks like pathfinding. At least part 1 is definitely pathfinding. This is, I start with all of those things off. This is a pattern on off. And I switch one of the lights by pushing one of those buttons. This is ignored in part 1, which is a huge hint that is going to be used in part 2. And I need to find the shortest combination of pushing buttons that does this thing. This can be translated into purely an int problem, because this is a binary thing, 0, 1, 1, 0, and this is flipping bit 3, flipping bit 1 and bit 3. So this is an XOR of 2 to the power of 3 and 2 to the power of 1 plus 2 to the power of 3. It can be rewritten as purely a series of XOR. So part 1 is fairly trivially a breadth first search where I start at 0, I apply a bunch of XORs of all of those things until I find a chain of them that gives me the right number, which is this target number here. Now, if I had not seen the spoiler on Reddit, I would have assumed that this would be some kind of edge cost. But since everyone is talking about using theorem provers and solvers, I assume that actually no, this is not the edge cost. I am of 2 minds about this. I am tempted to do part 1 as a normal BFS because I think it's interesting to write. And then we'll see what part 2 is about, and I'll see if I want to try something a bit smart before reverting to Z3, basically, if I can't find anything better. And I have as a dependency, because I used it last year, where is it? I checked earlier. SBV, there we go, there it is. So I didn't bash with no, wow. Yeah, I feel like lean might be appropriate for this. But yeah, there's this library SBV that I used last year, which is just like forks to bindings to other things like Z3 under the hood, and allows to write all of my bindings to Z3 in nice Haskell declarative code. So if I can't solve part 2 without a solver, this is what I'm gonna use. Okay, so let's try. Do I already have the input? I don't seem to have the input. Okay, so that's our nonsense. That's a lot of them. So let's start by doing the basics. We are gonna want to do some parsing. I'm gonna also copy the example here. I don't know how to parse the right-hand side because I don't know yet what it is. I don't know if it's a set. I don't know if it's a list. For now, I'm going to make it a list, and I'll change it if I need something else for part 2, since part 1 doesn't use it anyway. So that's our test input. What is our input? Our input is going to be a list of machine. And a machine is going to be the lights and the buttons. So this is going to be the lights, which is going to be an int desired lights. And we are going to have the buttons, which is going to be a list of int, because again, this can be reduced to an XOR problem. And we're going to have I don't know, which is going to be for now a list of int because I don't know what the thing is. And of course, we'll rename this in time. So this is a list. We're going to do a parse line with that's going to be the same. So parsing a line will be get the lights, then get the many buttons, and then I'm going to call it S because it looks like a set. The whatever that I'm going to rename when I know what this thing is. Although I guess I don't have to parse this for now. I can just rewrite, since I'm just parsing line by line, it's fine for my parser to not consume all of the input. I can rewrite this parser when I know what I'm supposed to parse actually. So that's going to be what we do for each line. How do we parse lights? Again, using parsec because parsec makes everything trivial. This is going to be the symbol this. Then at the end of this, we'll have the symbol this. And in between, we are going to have bits, which is going to be many 1 bit. And we return an int, which is the sum of I'm going to do this in list manager just for readability. So for the index and the bit, which is going to be 0 or 1, in zip 0 with the bits. Well, bit is already used here, so let's call it b. This is going to be b times 2 to the power of the index. Okay. What is a bit? It's going to be a choice between something is wrong somewhere. Yes, this is misaligned. It's going to be a choice between 1 if we pass the symbol pound and 0 if we parse the symbol dot. In fact, a character. I don't want to skip space here, although it's not going to happen anyway. Is that correct, actually? And this means on. Okay, yeah. So that's our choice for a bit. Now we need to decide what is passing a button. A button is passing the symbol open bracket. At the end, we pass the symbol closing bracket. And in the meantime, this is indices. And that's it's number separated by the symbol comma. And at the end, we do the same thing, but this time we don't have the booleans. It's purely the sum of, for each index in the indices, 2 to the power of index. So I can rewrite this as map 2 to the power of on the indices. Okay, let's try this. Let's print the test input for the example. Let's see what this looks like. And of course, wrong. There we go. Oh, yes, here I need to return at the end. I need to craft something with this. This will be a machine with desired lights L, buttons B, and I don't know, an empty list. I forgot to make machine an instance of show, so I can do print. And here I'm even going to do a traverse, so I put one machine per line. Okay, so here I am running the wrong day. Unexpected end of input. Interesting. Oh, because I have a backslash in here. I think that's wrong. So I have desire light 6. 1 plus 2 plus 4 plus 8. That's 2 plus 4, that's 6. 1, 2, 4, 8, that's 8. 2 plus 4, 6 plus 8, 14 plus 32, 46. That's correct. Perfect. And just to make sure, 0 means the first light, so I'm assuming that's this one, so that's the index. And so here this would be 0, 1, 2, 3, this would be this one. Okay, so that should be fine. Okay, and I don't know what the whatever is. So that looks correct. 3 is translated as being 8. 2 to the power of 1 plus 2 to the power of 3 is translated as 10. That looks correct. 2 to the power of 2 is 4. Okay. So now, part 1, what do we want to do? We want to find the fewest total presses required to correctly configure. Okay, so let's do, for part 1, a breadth first search. So here we're going to do, this is going to be, given our machines, this is going to be a sum, I can rewrite this actually just as a sum of map find shortest sequence. Nice. So find shortest sequence, and I already have in my library of Advent of Code functions a path finding that's actually a proper distra or even A star that is using some actual like priority queue and everything. Let's not use it for the sake of like showing how that works. So shorting the shortest sequence for a machine. So we're going to have the things in scope. We have desired lights and buttons. This is going to be, I'm just going to write it as, I'm going to make it a separate function, actually. So this is going to be, find shortest sequence, a function from machine to int. And this is going to be go 0, we have pressed 0 buttons. 0, we start with 0 lights on. And that's it, basically. So go, our recursive function, which will be tail call optimizable, which is going to be convenient for performance, will be taking our int, which is going to be the current depth, will be taking... Actually, it's going to take a set of lights. I don't know if I press a button never more than once. I don't think that's true. I think they have an example there. Actually, you're right. I think there's never a point. Actually, you're right. I think there's never a point in pressing the same button twice. You're absolutely right. Let's write it as a BFS, and I'll rewrite it as a finding a combination. Actually, the BFS might still be faster, I think. Because we're not gonna try because if we try all the combinations, we're gonna have to iterate over, like, try to iterate over one of them and just... We might not find... Wait, we are guaranteed to find... If there is a solution, we're guaranteed to find it. If there is a solution, we're guaranteed to find it. So if we sort... yeah. I don't know. Let's try the BFS. And this is going to return our int at the end. So actually, this is going to be our list of known state after that many steps. After 0 steps, we only know one state, which is 0 for the lights. And when we go and we are at depth 1 or whatever, and we have our current values, there are two possibilities. If the desired lights is within the values, this should probably be a set actually for performance. It's fine. Oh, did I... If there was a double entendre that was completely unintentional for once. So if we have found after that many steps one of the values is the one we want, then we return the depth. In fact, does hash set have... It's not exactly brute force, but it's not exactly... It's a bit naive, but it should be fine. I am, from what I've heard, it will never work for part 2 because the state is like billions and billions of possible combinations. I don't know what this value is used for, so I can't estimate why yet. I wanted to check, does this have some kind of concat map? Because there is a map from A to B, and I create a hash set, but that's not what I want. There doesn't seem to be some kind of concat map, sadly. That's fine, I'll just do it with lists. Because the only problem like this is LM is basically a linear search in the list, which is why this solution is kind of ugly. It's fine. It's absolutely fine. What do we do in the case where we didn't find our desired value after that many steps? I guess steps rather than depth. What we do is we go recursively with steps plus 1, and the values are gonna be a concat map, and I'm gonna do it as a list monad because I like doing that. This is gonna be, and I'm gonna do a nub here to deduplicate the list. I should do a nub ord. It's fine. This is going to be for each value v in our values, for each button in the buttons, return v XOR b. So we apply the button for each value after this many steps. And well, it's not exactly a fully brute force because we stop the second we found something. We're not going to iterate over a combination of buttons that are longer than the correct sequence. And the trick here is we deduplicate the list to make sure that we only have a set of, so it's going to be a limited set of values per round. This should be fine. It's a bit inelegant because, again, this is-lm is doing a linear search in our list. This is not very elegant, but it should be fine for part one, hopefully. Let's have a look at what's happening here when this compiles. Is lm not in scope? It's simply called lm. Oh, and I'm going to need... Actually, I'm going to at least do that. I'm not going to go for the most naive solution. Rather than using nub, as mentioned earlier, I am going to use nub ord, which is in data list extra. Because it's faster. Okay. Here... And I have to type this just to avoid a warning. The warning is not the end of the world, but I would rather avoid it. Likewise, trying to avoid. Okay, so this runs, and I get 7 for parts for the test input, which is correct. Perfect. Oh, I want to do something. I know this is extremely inefficient because we are using lists and we are doing lm on a list. I want to use control parallel strategies. There we go. Import control parallel strategies. And for part one, I'm going to replace this map with a par map. And this takes a strategy, and let's go with airpar. And now this map is in parallel. So we still have 7 for... In fact, for now, let's print the list of int so that I can check that those ints are correct for the test input. I get 2, 3, 2. Two, 3, 2. Okay, so that looks correct. And so for part one, this very naive thing gives me 488. Please be correct. And that's the right answer. So that was part one. Part one, not too complicated. Now let's see what the fuss is about. I can use to switch the buttons from configuring the indicator lights, okay, to increasing the voltage levels, okay. Are we gonna have to do both, or is part two purely about the voltage levels? The counters are all initially set to 0, okay. Oh, that is absolutely matrix computation kind of thing. That is a system of equations. That's purely what it is. Because what I mean is, so wait, does each button increase by one? Increase by one. Okay. So let me explain what I mean by being this is purely a system of matrices. This is basically, if I look at this example here, we want to obtain 3, 5, 4, 7. So let's name those four. I have 6 buttons. And let's call x1, x2, x3, x4, x5, and x6 the variables of how many times I'm pressing each button. What I want to solve is um 1, 2, 3, 4, 5. So x5 plus x 1, 2, 3, 4, 5, 6 x6 equals 3. Then I want to do for 1, this is 2 and 6, so x2 plus x6 is 5. For 2, this is 3, 4, 5, so x3 plus x4 plus x5 equals 4. And for 3, this is x1 plus x2 plus x4 equals 7. Now let's rearrange this a tiny bit. In fact, let's make it very explicit. This was here. This was 0. Sorry for taking the time to write all of this, but I want to make my point very clear, and also this it helps me think about it. Okay, and now 0 times x5 plus 0 times x6 equals... Wait. Did I inserted the line that didn't exist. Okay. So this is what we are trying to solve. So basically, this can be written as this for this line. We have the 6 variables that are just like how many times did we push a button. And this is, we know that 1 times x5 plus 1 times x6 equals 3, which is for our button 1. Oh, actually, should be 1 for x2, yeah. I lost some ones in row x2, you're right, yeah. For x2, this is 1 and 3. Wait, no. 1 and 3. For x1, it's 3. For x2, it's 1, 3. 2, 2, 3, 0, 2, 0, 1. There we go. So that is the system that we were trying to solve. And specifically, what we're trying to do is we are trying to minimize the sum of the x values, basically. That can probably be rewritten as a matrix multiplication, because I think that's basically, if my memory serves well, it is this matrix times the vector of the x equals this, basically. Something along those lines, right? It's been too long since I've done any algebra, but I think it's something along those lines. And this is supposed to be this. So I think this is something along those lines. This is clearly trying to solve a system of equations, but not just solve for x1 to x6, but minimize from x1 to x6. Should be to the right of the matrix. Okay. The thing is, I don't remember how to do that at all. So do I attempt to try a manual solution, or do I directly move to Z3, basically? Because this is trivial to express with Z3. Z3. Let me think about it for a second if I have some thoughts that are interesting. Because I think thinking about it as a system of equations means I'm not doing a BFS, I'm not trying to like graph things. My representation is purely int, which means in terms of like my memory exploding should be fine. Let me try to think if there's a smart way to do. I mean, what I'm planning to do is if I can't find a solution that is in Haskell code within myself, I just use this Haskell library that just calls to a solver underneath, and then that just solves it for me, basically. Yeah, the thing is, my math lessons are at this point 20 years old, and I don't remember how much I could do that. Oh, no, that being said, you could be right. You're right. I could do something. There is only one. Wait, no. There is no light for which there's only one value. Because if there was, I could find the value for that, for one of the x's, and then continue. Simplex algorithm. Okay. That is indeed maximize, in this case minimize, but it's the same thing. Okay. This would be interesting to implement, I think. But I think my knowledge is old enough that I would struggle to actually write it live on stream. Like as you can see, like writing a BFS like this, like is first try basically. This is the kind of stuff I know. Trying to implement the simplex based on 20-year-old math memory, unlikely to be successful on stream. Which, by the way, proves my point that you don't need to be good at math to write stuff in Haskell, because, you know, I'm not. But yeah, I think this is clearly the right approach. If I want to write it in pure Haskell code, I don't know how to do this. So this is a system of equations. I'm gonna use a solver for this, I think. This will be interesting for me, I think, to learn, but I think for a stream, it's less interesting if I'm just struggling to learn something live. So I'm just gonna use something that I know how to use, which is using a library. So let's import data.sbv. And I'm probably gonna need like as SBV. And I'm probably gonna need list as well. Yeah, but the thing is, like here for a stream, I might just end up spending, you know, an hour just reading Wikipedia silently. Doesn't make for the best stream. But I will absolutely have a look and try to implement this off stream on my own because I think it's interesting. But for the stream, I'm just gonna try to just find something with the SBV. So this is going to be, if I remember correctly, my usage of SBV. It still has link from last year probably. This would be an optimize with whatever this is, or optimize style, I don't care, or optimize lexicographic, perfect. So this is going to be the same thing. This is going to be a sum of parallel map of find. Oh, actually, I should rename this. This is the joltage. Oh, can I rewrite this as... I might need to rethink the buttons because I don't think I can rewrite this in terms of an XOR this time. Because then they would bleed in a... So here I think I need to rewrite the buttons to actually be list of int for each of them. So here I am not doing the sum. This is purely the indices. But here I'll do a button values is going to be a list of int, and button value values is going to be this sum is map sum of map to the power of on the buttons. which means here I need to use the button values. There we go. And now the jolt, so this is going to be the desired joltage. And so we need to pass our joltage. And how do we pass the joltage? This is going to be this symbol, this symbol. It's going to be the same thing as button, but with brackets instead of parentheses, I think. Yep, looks right. So this is going to be the find the shortest light sequence. And part 2 is going to be instead find the shortest joltage sequence. For a given machine. And this is going to be our optimization lexicographic thing. Lexicographic, is that correct? Lexicographic. And here we're going to basically say, I need those variables. And at the end, we will minimize on something, basically. Because minimize given some thing, which is going to be a list of values. Okay, so how do we declare this? We're going to need our button variables, which is going to be for each of the buttons. For each of the buttons, we have a list. We have a button. What do? We create a new variable, which I think is, if I remember correctly, is the S. Only 6 hours. Yes, let's let the stream run for 6 hours. That seems perfectly fine. I want match case. There we go. Can I make it not named? Unnamed. Yes, I don't need it to be named. So this is gonna be this button's variable, which will be an unnamed value. That's the variable. That's the name of. That's the variable in our system. So this is gonna be x1, x2, x3, x4, x5, x6, and so on. And I will want to add a constraint. How do I add this constraint? How do I want to express this constraint? Because again, I just want to express a system of equations. Because I'm not trying to say... Do I want to return the vertical slice, basically? I think I want to return the vertical slice. I want to return the... So that variable, I will want to return the ×1 or ×0, depending on... So if I go back to my matrix, I want to return the column, basically. So this is going to be... For each... This is going to be returning a list of... For each index in 0 to length of the desired joltage, or 1 to the length of desired joltage. No, it's not at 0. -1. And here I want to return the list element for... I am currently in the column for this row, which will be the value if... So if index lm button, then button var. Else 0, I think. Now I've done this for all of my buttons, I have... And in fact, no, god damn it. I will need the variables because I need to know what I'm optimizing. So I'm going to be returning button var and that list. Oops. So here, after I have this, if I do an unzip of the result, I will get the button variables and all of the columns. Okay. Now I know I can declare a variable to be... Is it declare? No, it's not declare. There is a way to signal to create a new variable that is just an intermediary result, basically, in the model. Symbolic integral numbers, no. Create symbolic values. No, that's what I was looking at already. I'm looking for a function which is give a name to a particular expression. I thought there was one already. Logical aggregations? No. Those are the functions to cool the proof or something, it's not what I want. Named constraint and attributes. Is that something that I want? No, but it's on the right track, I think. Ha, where is that thing? Oh, wait. Is that exactly what I want? Do I want to? I want a from an SBV value. Create a bunch of free variables. This looks like the right thing. I want basically something that allows me label. There we go. Because I will want label, which is gonna be this is gonna be minimum pushes. That's a terrible name. Fewest presses. There we go. And that is going to be the sum of my button variables, basically. And I will want to minimize. That's going to be my target. And this will minimize my target. And then I will be able to extract this named value out of the model. Okay. Now I need to, I have the columns. So if I transpose them, I get the rows. And now I can say for zip the rows with the desired joltage, and that gives me the equation and the value. Sum of the equation should be equal to the value. This is probably wrong in the sense that I'm using the basic sum thing, so this might be actually the SBV sum. But otherwise, the details might be wrong, but the gist of it is I create a button, a variable for each button. I create the column of either the button or zero for my matrix, basically. I then transpose that to get the rows for each joltage, and then I say the sum of that row for each row is equal to the value. I'm just gonna say this is row, and I name then the thing I'm trying to optimize is my target, which is the fewest presses. Oh, sorry, I had missed your message. Thank you for tuning in. This is aha. So I'm gonna hide. I'm actually gonna import this one as qualified just because all of the list operations will otherwise conflict with the prelude ones, and I don't want to do that. Aha. So there's no sum in SBV list. Well, that's exactly what this is. So I'm surprised there's no sum. Oh, wait. Sum is right there. Data SBV list does not export sum. Wait. This is SBV 1012. Am I looking at the right version of the documentation? Thank you. Package this down. Oh no. Oh no, package this down. And yes, this was indeed a typo. Thank you. Um, I oh, wait. This is SBV 13.3. I can see this here. I am on a way too old. So that means somewhere in here in the stack YAML probably. Yeah, so I probably want instead 13.3. And I want to use the latest version. And I'm going to keep this page open. Oh wait, if package is down, well, unless only the documentation is down. Okay, it seems to be back. At least. So now we wait for the newest version of SBV to be installed. What's happening to Hackage? Well, welp, that is a bit annoying. Okay, so if I change this back, can I build the documentation locally based on the installed dependencies? So that I can access at least I can, if I can do that, I can read the documentation of the installed version of the Haddock. Flags target, thank you. So can I try cab? Let me put this where it's visible. Ten 12. Nope. Ah, the target is a local target. Okay. And can I see the flags? Doc. Flags. By the time I figure this out, Keval will be back, but Reinstall. God damn it. If I just do a Cabal Haddock, what's happening? Oh, it's redownloading stuff. The fact that it's successfully redownloading stuff either means it's hitting the cache, or it means Hackage is back. Let's try. So which version will we see? 13.3. Yeah, I think Hackage is still down. Yep. So let's hope that this is actually managing to hit the cache and install the documentation version of... But this calls Haddock. So where does it put the... I wonder if it's putting it in a temporary place and I'll find it afterwards. Or would it be actually in stack work? No. Ah, it seems to be back. It seems to be back. Perfect. So if I go back to package, so I will figure out how to do this offline at another time. So I was... Oh, okay. They've deprecated everything before. So I should upgrade. So I'm just going to kill this. And I'm going to rerun this with the current version. And hopefully Hackage is back enough that actually the fetch succeeds. I'm curious, in case it's not coming back, I had 1012. Maybe I was a bit optimistic on it being back. That's probably mean I have too old of a resolver in my stack YAML. I am on LTS 2243. If I want SBV, This version is deprecated. Okay, but I still seem to be able to load the thing. There we go, it's back. Okay, perfect. So if I use the old version, there is no sum function in this, but I could probably rewrite it as a fold, because there is a fold. Perfect. However, if I manage to switch to... So on the LTS, even on 2423, it's the 11.7. And 11.7 is still listed as deprecated. So I would need to switch to nightly to get... With stack, I would need to switch to nightly to get that. Unless I were to force a newer version. Well, I suppose this is still technically a Haskell stream, and this is now dependency hell and dependency management. And working around a hackage outage, I suppose. This doesn't have sum, I think. Yeah, doesn't have sum. Okay, so I won't have sum anyway. On stackage 2243. I want to look at the one I currently have that I don't want to change. Can I look for... I want to look for a specified version. There we go. So the 2243 SBV, which version does exist in there? That's not what I want. It's 10.2. What was this in the first place? God damn it. Good enough. This was... $10.12. Well, let's keep it the way it was. Let's not change this now, especially since that way I can continue compiling with the one I have installed, even if hackage is broken, which means I will just instead do a fold L with plus and 0. All that for that. That's a label. And this is not going to give me an int, it's going to give me a model. What do I have another sum? Oh, yes, of course. I am tempted to introduce the SBV sum, or variable sum, which is this thing. There we go. Transpose, not in scope, but I have list transpose. This is the plural button variables. And here this gives me the output So I will want to try to see if I can find 10, 12. Okay, that's what I have. Perfect. This gives me a SMT result. And I will want to do something to extract something out of the model. Get model value based on a string. Okay. So this is going to be get model value with the result name. And here I'm going to do a horrible from just, because I want to guarantee that this worked. And the result name is a string, and it is this uniquely identifying string, fewest presses, that I'm going to reuse here. Result name from just non-scope. This is pure. Is this an assert? Or is it named differently? S assert, probably. Okay, let's have a look at... Why am I on string? I don't know. I am looking at this equal thing that I've been using. It gives me an S boolean, okay. Okay, so this is indeed the thing that must hold. Wait, let me have a look at grep SBV in 2024. I can't type, I swear. Day 13. Okay, we had SBV and SBV list as SBV, that was the same. Constraint is what I was using. Okay, so this was exactly the same thing. This was the A button, the A variable times this plus, yeah, okay. So constraint is the function I was using rather than assert. Constraint give something that is quantified. Okay, so I can probably try just constrain here for my day 10 instead of assert. This is constrain. I am missing a few things. Aha. Okay, so how does that work? Because this fold that I know exists in this version of SBV. Given an S list, which is what I have. Oh, wait, no. Expecting S list of string, and I have. Aha, so that's not what I have. How can I make a implode seems to be what I want. So rows would be SBV implode of transpose of the columns. We're getting somewhere. And this is just a let, not. Okay. Oh, so I have to map SBV implode and then SBV implode on the result. Oh, wait, I don't have to do that. I just have to map SBV implode. There we go. And now this is a value that I'm using in equal them. So it needs to be an SBV value. And how do I create? I thought those had. Oh, maybe I just need to do from integral on this. Okay. Oh, so this is just a let there again, not something in the monad. So this is going to be again a SBV implode. We're getting close. Is applied to too few arguments. Oh, is it just the name? Did I create the, did I search for the label for nothing? Maybe I have. Minimize. Oh yeah, name of goal. Okay. So instead of doing this thing, I can just say minimize result name. And it's this. Okay. Except int is not a known thing. So this is going to need to be an int 60. Well, I hope it's not an int 64. But let's use int 64 anyway. It needs to be a bounded int. So this is going to be int. And this therefore returns an int 64. Oh, and this is now in IO because it binds to the solver underneath. So this whole thing is now in IO. So now I'm going to rewrite this as being in IO. And at the end of this, we return this. Which means at the end here, I need to switch. This is no longer print of the result. This is print of bind the result. Okay. Could not solve is non-zero and 0. Okay, so I need to probably specify that this is an sint of int64. So probably just sint64 then. Here I am doing this par map, which is my control parallel strategies. Is there a traverse instead? If there isn't, what I'm just gonna do is a sequence to traverse to transform that list of IO action into an IO result, and then fmap the sum. Okay. I think I have a suspicion this is wrong. I think this is incorrect. I think this is extremely incorrect. Okay. Oh, yes, I should probably also add a constraint that the button variable must be greater or equal to 0. Because otherwise, I'll try to minimize by doing a multiplication with something negative, which is why we had such a weird result. Oh, this is probably not the operator. I need to have a look at the operators. Wrong file. Where's this define? Here. There is the EQ symbolic. And is there an ORD symbolic? There isn't. Great. So wait, so how do I compare? How do I say greater than? If there's no operator for this, there must be some kind of... Oof, that's too many matches. There must be some kind of... constraint and quantifiers. That's probably one thing like this I want. That feels very inefficient. Okay, so how do I say this feels like it should be easy? Okay, divisible model. Like a lot of those are. Wait, is it just simply that there is a. Nope. Oh, there we go. That's on booleans. Ah, there we go. Where is this one defined? Oh, right there. Or it's symbolic. I searched for it. So what I want to express is this. Took a while, but we found it. So now I find 33 for the test input, which is correct. So now we just let the solver run and we hope that it finds the right solution for our real input. Because I don't feel like re-implementing the simplex live on stream. This is slow. Huh. Interestingly, the CPU is not. Okay, yep, Z3 is using 100% of. It's using a full core. Oh, but since this is in IO, I probably. I know what's happening. I know what's happening. See the par map air par here? It parallelizes creating the list. And creating the list is applying this function to each of the elements. So we parallelize creating a list of IO actions. This sequence is not. Which means we have parallelized creating the list and then evaluating the list is sequential. So let's see if there is a way to. Yeah, so instead I'm going to replace this with a traverse to create the IO thing, and then in IO I will be doing a sum, but before that an eval list air par, which hopefully will run this in parallel properly. Oh, I see. So this is an eval sec of eval list. Wait. No, I'm using the wrong thing. Using with strategy. That's the right function. There we go. And now, hopefully, we should see the CPU being very unhappy. Unless there is some kind of mutex that is preventing calling multiple Z3 instances in parallel, because this is still only one Z3 running at a time. Let me test something in GHCI in the meantime. If I GHCI import control strategies parallel strategies, it's not loaded. Let's do a stack GHCI so I have access to it. And then what I want to do, I want to check something. So if I have a function foo, and foo of x does a print of replicate 10 of show of x. Now, if I map foo on 0 to 100, I get a list of IO actions that I can sequence to get all 100 actions that have executed one by one. Now, if I do my par map air par here, it's gonna create the list in parallel, but not evaluate it in parallel. So I think what I want to do is traverse that. And then here, I want to do this with strategy eval list. Right. Oh, yes, this is an fmap. There we go. Oh, this still seems to be not in parallel. I was expecting this to fail and start printing things that are overlapping. Oh, it might be simply... Wait, could it be simply that I am not running... No, I am running with N4, but GHCI is not probably. So GHCI is probably not running with parallelism enable, which is why I'm not managing to print this list in parallel, even if I'm using this thing. Well, now we wait. Well, Z3 is using 100% of my CPU. I'm surprised it's this slow, to be honest. I'm tempted to make some changes just to try to see if I can make it faster. Because I could try to eliminate buttons I used. I could try to do some things there. Yeah, one thing... no, I can't... No, I can do that. Let's try this. Let's see if it makes a difference. Rather than doing this thing where I put zeros in the column where the variable is at use, let's put nothing instead. And here, let's map cat maybes. So that I don't have a bunch of zeros. I don't know if it's going to be any faster, but one thing I'm going to do as well is I'm going to do I want to see how fast it's going, basically. So let's just do the traverse. And here, let's do the traverse print. Oh shit, for the first one of my real input, it's taking that long? I guess it's a bit bigger. That's terrifying. That's gonna run for hours. I guess trying to minimize 7, 8, 9 variables is a lot. Still, I don't know it's taking so long. I'd like to at least... I'm okay with letting it run overnight at this point, but I'd like to see at least one result being printed there. Oh, I guess this is also like I'm doing an increase by 1, and this is up to 84. So it means, yeah, those are big values it's supposed to find. I don't know. At least it's correct on the test input. So there's that. And in terms of amount of code written, this is definitely the simplest I could do. I'm using this opt lexicographic. Is there a better one I could be using? Optimize style. That's purely in which order to optimize the objectives, and I've only given one, so that's fine. Perhaps I could, instead of saying, oh, this is an arbitrary int and it happens to have a constraint to be greater than 0, could I instead use a non-zero value or something like this? Yes, I could use an word. I should try that. Let's try this. Let's replace int 64 by, and let's say there's probably never gonna be a need. Yeah, all of those values are small enough. So let's say instead a word 16. Which means I can remove the constraint here. Because now this is an unsigned value. Well, it's wrong now. So it's printing a lot of results very fast, but they're all very wrong. Yeah. So perhaps we should rethink this. Why did changing to an unsigned value fail? That's terrifying. Because now it completes quickly, but it's wrong. So I think the thing is, I think I'm on the right track with reducing the number of constraints and reducing the size. But why on earth would changing to something like this give me a wrong answer? That's fascinating. So there's two options. Either it's the size or it's the fact that it's unsigned. So let's try. I minimize over the sum of variables. So the thing I'm trying to minimize is purely the sum, not the individual variables. So here, since I'm back to in the signed world, let's go back to greater or equal to 0. Okay, so that's correct here. So switching to an unsigned value doesn't work. Why would changing to an unsigned value not work? That is fascinating. Because I'm not doing anything super complicated. If I keep this constraint, it's useless because it's still wrong. Incredible. So it tells me 0. Okay, time to debug something then. I hope this thing have a show instance. It does. Ah, great, it's symbolic. Wait, why do 1, 2, 3, 4, 5? That's way too many rows. Oh, because it prints all 3 there. So it does the parallelism correctly. Oh. $15, 4, 9, 15. So it is indeed 1 per. Okay. Why on earth is this wrong with 0? The value might not be, it's an int. So I will need to do a from integral of the value as an word 16. That looks fine in terms of conversion. That's not a problem of... Is it a bug in this library where it doesn't work with unsigned values? What on earth? What is happening? Is there a way to print the symbolic value? So if I have a symbolic value, an SBV, can I get the name? But it might not have a name is the thing. Why does switching to an unsigned value break everything? What on earth? Well, the thing is, maybe it's faster because it's broken, and therefore the speed difference is irrelevant because it's not the result of an optimization, it's the result of it being wrong. I am extremely confused. Okay, can I do instead a print of the model then? Nope. But maybe this STM result thing has a SMT result, has, if not a show instance, at the very least some function to get the model data. I'm using get model value. Extract model. Let's see, and that works. It doesn't know what this is supposed to be. Get model dictionary. But I didn't name my variables, so that's not going to do much, because it's just going to tell me that my objective is 0. Aha. So fewest presses is 0, because S0, S1, S2, S3, S4, is that just a problem of... Is that just a problem of, okay, it finds... Is it just an overflow, basically? Well, I can constrain them to never be more than the maximum of the maximum voltage that we require, because since each button increases by 1, there is never a button that's going to be pressed more than... There's never a button that's going to be pressed more than the value of a line on which it appears, which means max presses per button is the maximum of the desired voltage. There is never a button going to be pressed more than this, which means I can constrain that the button var is less or equal to the max presses. And now, even if it's a word that is unsigned, and this is a from integral, and now this seems to be working. So it was doing the overflow, and it seems to be a lot faster as well, which we like. So remove all of those prints. It's not that fast. Okay. It is 12 seconds, including compilation. I'll take it. That's not too bad. So now we can go back to this. I don't see Z3, which is a good sign. Yeah, 8 seconds total for both parts. Let's see if this is the correct value at least. It was. But I don't feel very proud of it. This was purely Z3's magic. It's okay, so my big mistake, I think the word 16 versus int64 is completely irrelevant. I think the big mistake was not constraining the maximum value of the button, and therefore the model was searching absurd values for other things, and in fact was using overflow for the other things. I suspect that if I switch word 16 back to int64, so back to signed, back to, and I re-add import data int so that I have int64, and I add a constraint that it is greater or equal to 0. I suspect this will be the same speed, and the unsized thing, the constraint, will not change anything, basically. This looks a bit slower. Maybe I was wrong. Maybe not having the constraint and therefore being able to eliminate some entire values just because we don't have to iterate over them was better. So maybe the word 16, word 32 thing was better. Yeah, this is definitely slower. I was wrong. So let's. Okay, so yeah, 40 seconds. That's definitely a lot worse. So let's go back. And I suppose let's try just a thing. Let's see just I would expect the word 16 to not be required and word 64 to be just fine, word 32 even. Because I think now that we have the constraint, we have the one constraint on the maximum value, I think it's going to be just fine with this. I think the model was starting by doing the enumeration of the values, and from int min to 0 is like, let's try this value. Oh, it's not validating the constraint. Let's try this value. Oh, it's not validating the constraint, and iterating over all of the ints. Therefore, yeah, there we go. That's fast. Although it might be slower if we're still iterating over all of the values and just stopping the constraint. Can I restrict? It might be slower than the word 16 for that reason, actually. It is slower. So I assume that's how it works under the hood. Is there a way for me to restrict, not with the constraint, but with. Can I restrict a variable to a specific set of values? Because that's what I want. I want to avoid the model considering values that are completely irrelevant as part of its minimization. Well, I hope it's not just doing a brute force. That'd be. Wait, wait, wait. Wait, wait, wait. And this is a flip map test, a real input of this. Okay. No, okay. I was looking at the amount of iterations that a brute force would take. This is the worst case for a brute force, where for a machine, we take all of the possible desired values and we try pressing all of those buttons that amount, and we just do that for all of the buttons, basically. That would be the brute force is that many cases for the worst machine. So yeah, brute force, not a good idea. I mean, we were expecting as much, but it's still good to verify. Oh, can I actually check something, which is what's the maximum of concat map desired joltage of the real input? It doesn't fit into a word 8. That's good to know. Because now what I want to check is there a way for this thing rather than like iterating, like clearly it's iterating on some values that I don't need. Can, instead of using a constraint, can I make it so that it's a for all within something? Let's see. Aha. Well, no, this is creating a list. That's not one of what I want. Because if I could, instead of saying this is a word 16 that happens to have a constraint that it is less than some maximum, if I could instead put a constraint of like at creation time saying this is a free variable which is one of those values, that would save me a lot of work, I think. But I don't know how to do that with this library. Well, oh well. I've given it a try. I think the word 16 approach is still the fastest. But clearly, if I increase the size of the variable, it spends more time looking for things despite the constraint being there. Which means if I use a sign value, it's still considering negative values and then filtering them out because they don't match the constraint. And here it's the same thing. If I put a bigger unsigned value, it's going to consider more values and just filter them out thanks to the constraint. But it would be a lot better if I didn't have to say, of all of those possible values, constrain to those, and instead say, well, this variable is one of those possible values. And I don't know how to do that. I'm going to have a quick look again, just to make sure I'm not missing something obvious. It's still down to 8 seconds, which is not the end of the world, but it's not great. Because yeah, all of those are just versions of free. Yeah, I don't know. Those are weird things. Oh, probably from the examples. Yes, from the examples. That's why. Hence, pet and inhabitant and a few others. And beverage. Yeah, I don't know how to do that. So I am not gonna bother any further. This is not interesting. This is just me reading documentation. This works despite being ugly as hell. Well, ugly as hell. It's not that in terms of the Haskell code, it's not that bad. It's just it feels a bit sad to just be using the solver rather than writing something a bit more manual. Wait, why? What is this printing? Yes, of course. Hmm. I wonder if I could make it. I wonder if I could create my own type of variable and then make it so that it's. Yeah, I don't know how to do any better than this. And I think just me reading documentation silently is not super interesting. Oh, sorry, I had missed your message. Do I reduce the number of variables first by the matrix and then minimize, or do you just minimize over all of them with the matrix as constraint? I do the latter. I do the latter. What my code does here is basically for each of the buttons, I declare a variable for that button, and I return for each of the targeted values for which that button does something, I return that variable as in the list. I create a list of like maybe values. So if for the first value, first joltage that button is used, it's just that variable, otherwise it's nothing. Then here I get so my variables and their associated columns, and I do a transpose of the columns, so I get the rows. So I get one row per value of the desired joltage thing, and I just say that my I add one other constraint, which is the sum of the variables of that row is that value, the desired joltage, and then I minimize not the variables individually. I minimize just the result. I minimize the sum. I suppose I could try to minimize the variables individually, see if that makes a difference. Like, what happens if I minimize the button variable as well? I need the button name. So I'm gonna need to zip which means here now I could have the button name be button plus show button index. This becomes this with the button name, so now I have the name of the variable. And here I should say I am minimizing button name plus value. This takes a tuple since I've used a zip. That button index is an int. Well, it's wrong. Here, if I try to minimize, so it's probably gonna try to find one of the minimize, and therefore, so I should use another option then. God damn it. I should try to use another option, minimize. Because I assume it means, yeah, it's completely wrong. But that's probably because it's trying to minimize the wrong thing. This was the thing we were looking earlier. Aha. Objectives are optimized in the order given. Earlier objectives have higher priority, which means it's minimizing the variables first rather than the sum. So if it finds a solution that minimizes the first variable before minimizing the sum, it would choose that. So minimizing the variables is, I think, not the right approach. Because since it's going to minimize... Well, unless I switch to... Yeah, if I switch to independent, it will try to minimize... Yeah, since in this case I'm not trying to minimize each thing, I'm just trying to minimize the sum, I think removing this minimize is the right way to go. I guess the only upside is now I have a name for the button, but I don't really need it, so I'm just going to remove it. Which means we're back to this here. Okay, well, I mean, it works. I'm still unhappy with it in terms of like, this could have been better, this could have gone better. Although we had to fight with a hackage outage, which is not completely my fault. But it could have gone better. But, you know, it still gave me the right result first try. I'll take it. But I think, yeah, if I have time during my end of year vacation, I'll try to learn how to implement the simplex algorithm manually so that at least I know how to do that and figure out how it works under the hood. I think that would be interesting to do. And I don't think it will be faster than like 8 seconds, but still probably fun to try. Okay, I'm gonna stop here. I don't think there's any problem that we've done today that I want to try to do in Brainfuck or at the Haskell type level. I think neither problem is well suited for this. So I guess no. I think day 9 is doable in Brainfuck. The only problem is the areas I'm supposed to compute don't fit into an int 32, which means I would need to add some basic int 64 handling, and that sounds like a nightmare. So I am not going to do that. And instead, I'm going to go sleep. And maybe tomorrow I'll have time to work on the compiler after the stream, depending on how much work there is to do tomorrow. In the meantime, well, thank you everyone for tuning in. Today was a bit more complicated, but we got through it, and we'll see what tomorrow brings. Bye, everyone.